Section 8.7 is titled Slope-Intercept Form. So the objectives of this lesson are to determine the slopes and y-intercepts of lines, and then also be able to graph linear equations using the slope and the y-intercept. So first let's talk about what slope-intercept form. It's an equation of a line that's in the form y equals mx plus b, where m is the slope and b is the y-intercept. So when you're looking to find what the slope of the line is, we look in front of the letter x, and it's the coefficient attached to the x, and the y-intercept is then the constant that's added onto the back of the equation. So what I have here is a graph drawn, and I've kind of blown it up a little bit so we can see it a little better. But remember what y-intercept represents. It's where the graph of the line crosses the y-axis. So you can see here is the y-axis. Remember, it's the vertical axis, and the line crosses the y-axis at positive 1. Remember, when we name that ordered pair, it's 0, 1. So that means that the y-intercept for this line is at positive 1, or 1. The slope we determine from counting from one point or one ordered pair on the line to the next. So you can see another ordered pair that's been labeled here or plotted is 1, 3. So if we count from here over, we go up 2 and over 1. And I've kind of written them over here on the right side as it was kind of hard to see here in the middle, but up 2 over 1. So that puts the slope for this line at 2 over 1. Remember, rise over run. So if slope-intercept form is y equals mx plus b, we said the slope was 2, so y equals 2x, plus the y-intercept is 1, so y equals 2x plus 1 would be the slope-intercept form of this equation. Recognize that it's called the slope-intercept form because it gives us two pieces of information about the line. It gives us the slope and the y-intercept. So first we want to be able to look at equations that are written in slope-intercept form, or equations of lines in general, and be able to state the slope and the y-intercept. So for number 1, we have y equals 1/4 x minus 6. So we want to state the slope, and we label that m, and the y-intercept, which you can call it b, or you can actually write y-int if you'd like. So remember that the slope is the number in front of the x. That's going to be the positive 1/4. The y-intercept then is the constant that's added or subtracted in the back, and we need to make sure we take the sign with it. So in this case it would be a negative 6. If we were to graph this line, it would cross the y-axis at negative 6 and have a slope of positive 1/4. Let's look at number 2. Slope and y-intercept. So remember again, the slope is the number in front of the variable x, which is a positive 3, and the y-intercept is the constant that's added or subtracted to the back. In this case, it's a positive 1. This graph would cross the y-axis at 1 and have a slope of 3. Number 3, we have y equals negative 2x. Again, our slope is the number or constant, or excuse me, coefficient in front of the variable x. In this case, it's a negative 2. And the y-intercept is the number that's added or subtracted onto the back. And you'll notice here there is nothing back there. That does not mean that the line does not cross the y-axis. What that means is that if there's nothing back there, we could write a plus 0. So this line actually crosses the y-axis at 0. And if you think about where that is on a graph, that would be the origin. That's where y is 0. Let's look at a couple others that are a little more complicated. We need to state the slope and the y-intercept, but you'll notice that this is not in slope-intercept form, y equals mx plus b. We need to put this equation in slope-intercept form by moving the x term to the other side of the equation. So how do we move terms to the other side? Well, if it's a negative 4x, then we want to add 4x to both sides. Essentially, we're solving this equation for y. We want to get the y by itself. So that'll give us y equals 4x plus 2. And we should always write the x term in front of the constant, since that's what slope-intercept form looks like. So now we need to label the slope and the y-intercept. So you go ahead and do that first. So pause the video, pick out the slope and the y-intercept, and then see if you get it right. The slope on number 4 should be a positive 4, and the y-intercept a positive 2. Similar on number 5, we need to get the y term by itself. So pause the video here, solve the equation for y so that it's in slope-intercept form, and then pick out the slope and y-intercept. First, we want to be subtracting 6x to the other side. Why are we subtracting? Because we need to do the opposite. 6x is positive, so to move it to the other side, we subtract. So that gives us y equals negative 6x minus 3. Watch the sign there. So now we have the slope of negative 6 and the y-intercept negative 3. A few more examples here. Again, we want it in slope-intercept form before we start picking out the pieces. In number 6, again, we want the y by itself. Notice there's a 5 being subtracted from it, so we're going to add 5 to both sides. In doing that, we get y equals negative x plus 5. Now we can pick out our slope and our y-intercept. Notice here, though, there doesn't appear to be a coefficient in front of that x. There is a negative sign, and remember, when there is a negative sign, there is actually a number there. We just don't typically write it. And what is that number? Well, hopefully you're saying it's a 1, or in our case, a negative 1. So the slope here is negative 1, and the y-intercept is 5. Number 7, we have x equals 2 minus y. Again, we want the y by itself. Right now we have a 2 minus y on the right-hand side. We want to get the 2 to the other side, and notice that the 2 is positive. So we're going to subtract 2 from both sides. Be very careful with your signs here. That gives us x minus 2 equals negative y. This equation is still not solved for y, because the y cannot have a negative in front of it. Remember again, what is that? That's actually a negative 1. So we need to divide everything by negative 1. That includes the x and the negative 2. So then we get on the left side, if we take a positive x and divide it by a negative 1, that's going to make the x negative. If we have a negative 2 and divide by a negative 1, that's going to make the 2 positive, and the negative y divided by a negative 1 makes the y positive. Now I'm going to rewrite it just so that the y is on the left. So we have y equals negative x plus 2. My slope then is a negative 1, similar to problem 6, and my y-intercept is a positive 2. Make sure you study that problem for a few minutes and you really understand why we solved the equation the way we did and why we divided by negative 1. Now let's look at an equation that's in slope-intercept form and actually graph it. So the easiest thing to do here first is we want to make sure it's in proper slope-intercept form, and it is. Y equals mx plus b. We want to pluck out what the slope is. Hopefully you're saying negative 2/3. It's the coefficient in front of the x. And the y-intercept is a positive 3. It's the number that's added or subtracted in the back. So now that we know what the slope and the y-intercept are, we're actually going to graph the line. And you'll find this much simpler than making a table and plotting ordered pairs. So we always want to start at the y-intercept. Remember, this is where the graph crosses the y-axis. So we're going to locate positive 3 on the y-axis and draw a dot. Our line is going to go through this dot. From here, we're going to use the slope. First, we want to notice that it's a negative 2/3. So our line is going to go this way. decreasing from left to right, we want a line with negative slope. So if it's 2 over 3, remember it's rise over run. I'm going to start here at my y-intercept. Don't go back to the origin, start at the y-intercept. I'm going to go up 2 and over 1, 2, 3, and make another ordered pair. From this ordered pair, I'm going to do the exact same thing, up 2 over 3. And make sure you're counting correctly. Remember, don't count where you're starting. Now that I've gone 2 in that direction, I'm also going to go 2 in the other direction. So now pay attention to this. If I want to go down 2, because I want to extend my line more this way, over here, if I go down 2, I need to go to the right 3. Notice that's going to continue my line. Again, down 2 over 3. And now you see we have 5 ordered pairs on our line, and we can connect the dots. Remember, lines have arrows on both ends. So there's the graph, y equals negative 2/3 x plus 3. We started at the y-intercept, and we used our slope to plot 4 additional ordered pairs. And we'll do that every time. So when you're graphing using slope-intercept form, I want 5 ordered pairs on your graph. Let's look at another one. We have y equals negative x minus 2. We want to state the slope and the y-intercept first. The slope, again, is the number in front of the x. Hopefully you're saying negative 1. And the y-intercept is the number that's added or subtracted in the back, negative 2. We want to start at the y-intercept. We need to locate negative 2 on the y-axis. That's down here, and we plot our first point. We're going to use the slope, which is negative 1, to find our next series of ordered pairs that are on the line. Here we want to be careful. Notice it's a whole number, and we think about slope as being rise over run, so we're going to write this as a fraction. I'm just going to say negative 1 over 1. You can always put a whole number over 1. So now that means I'm rising 1 and I'm running 1, and it's in the negative direction. So that means, again, my line needs to decrease from left to right and be in this general direction. So from the y-intercept, remember this is where you start. I'm going up 1, over 1, up 1, over 1, up 1, over 1, up 1, over 1. And I could continue that pattern all the way through the graph. But now I want to go the other direction. I want to get some more of the line drawn down here. So it's down 1. And in order to continue the line, I need to go this way. Notice if I went down 1 and this way, that doesn't make a line. I need to make a line. Down 1, over 1. Down 1, over 1. Down 1, over 1. And again, you could continue that all the way through. You need at least 5 ordered pairs. The y-intercept plus 2 in each direction. So I'll highlight the ordered pairs you would have to have here. There's this y-intercept. There's 1, 2 in that direction, and 1, 2 in that direction. I just did a few extra because this slope is pretty easy when it's 1 over 1. Here's the last example, y equals 1/3 x. I want you to pick out the slope and the y-intercept and then try to graph the line on your own. So please pause the video and then check your work when you're finished. So here we have slope, y-intercept. The slope is the number in front of the x. This time it's positive and it's 1/3. There is no number back here. Remember from an earlier example, that means that the y-intercept is 0, because we could write y equals 1/3 x plus 0. When the y-intercept is 0, it crosses the y-axis at 0, which is the origin. And from that origin, from that y-intercept, we are going to use our slope. It's a positive 1/3 to find our next series of ordered pairs. Remember here, this is positive, so now our line is going to increase from left to right, or be in this general direction, if you can see my pen kind of tracing there. So from the y-intercept, up 1, rise 1, run 3, Notice I'm going the other way this time because I want it to have positive slope. Again, up 1 over 3. There's 2 in that direction. Now if I want to go the other way, down 1 over 3. Again, down 1 over 3. And that one's a little low. And now you can see our line. It does have positive slope. We can connect our ordered pairs and making sure that we've got arrows on the ends. If you wanted to do another few points, you could, but you need to have a minimum of 5 when you're graphing using the slope and the y-intercept. So if we go back to the objectives, are you able to determine the slopes and y-intercepts of lines? Go back and look at examples 1 through 7. Can you graph linear equations using the slope and the y-intercept? Those were examples 8 through 10. Remember, if you have questions, to be asking in class, and we will work on worksheet 8-7.